everyone, so today we're going to review Lewis acid-base reactions, which is a topic in Organic Chemistry 1, and it's super important. You need to know it in order to succeed in Organic Chemistry 1. So, as you know, Lewis acid is a compound that accepts an electron pair from what? From the Lewis base. And the Lewis base is a compound that donates an electron pair. So you might be wondering how to identify Lewis acids or Lewis bases in reactions. I'm going to give you a couple examples. So for Lewis acids, compounds that are generally Lewis acids and are able to accept an electron pair are cations such as Cu2+ or Fe3+. These compounds lack electrons, so they'd be real happy to accept an electron pair from the Lewis base. And another one would be H+. That was a cation as well, and it will be happy to accept an electron pair from the base. And another type of compounds are atoms or molecules that have an incomplete octet of electrons, such as BF3 or ALF3. If you draw the structure of BF3, it looks something like this. And there are no electron pairs on the B in the center, so that makes it a Lewis acid, and it wants to accept an electron pair from the Lewis base. And lastly, we would have something like CO2. The structure is like this. The C in the middle can definitely accept an electron pair, and one of these O bonds can break. This one is less natural, but you'll see it in reactions and you'll notice it. So next we have Lewis base. So how do we identify Lewis bases in reactions? They're usually negatively charged, such as OH- or CN-. You see these are ready to attack a Lewis acid and share them the electron pair that they have. Or something like NH3, which has an electron pair ready to attack a Lewis acid with it. Or CO, that has an electron pair. Or H2O, that one has an electron pair as well. So now that we know what Lewis acids and bases are, we're going to move on to some examples of Lewis acid base reactions. So I've organized Lewis acid base reactions into two categories. The first one is where no bonds are broken. So we have this compound over here which is positively charged, and we have the water molecule that has two sets of electron pairs on the oxygen, which is the central atom. And here, this water molecule, if you notice, is going to act as a Lewis base, because as you can see, it has these electron pairs and it's going to attack this C that is positively charged. So if I were to draw the arrow, it would go from these electron pairs to the central C. And as you can see, there are no bonds being broken. That's why this is in the first category. And the product would look something like this, just with a new bond being formed in between carbon and oxygen. So this oxygen is going to be positively charged now, as we can see here. So the second category would be where one bond is being formed and one is being broken. So one bond formed, one bond broken. And a good example of that would be water reacting with an H2 negatively charged. So in this case, notice how in the second case, water is going to act as a Lewis acid because it's going to accept the electron pair from the Lewis base, which is the nitrogen, the NH2. So we have the Lewis base here. And that is only because we have this nitrogen in the middle, which is negatively charged, and nitrogen does not like that at all. And oxygen is more able to handle that negative charge. So if we want to draw the arrow, we'll draw it from here. It's going to grab the hydrogen. It's a base, so it'll go for the hydrogen, not for the oxygen. And now this bond in between the hydrogen and oxygen is going to open on the oxygen. So the product looks like this. Negatively charged plus NH3. And yeah, that's pretty much about it. Please let me know in the comments down below what you would like me to cover next. And bye!